Hello, I bring you today the topic of naming and formula writing for ionic compounds. Um, to start off with, I would like to remind you, ionic compounds, they are made from one metal and one non-metal element. So once again, the metals, they're on this side of the periodic table, okay, to the staircase. All these are metal elements, and on this side we have non-metals, okay. All of these are non-metals, including a hydrogen as well, okay. So we're gonna need a metal and a non-metal to have an ionic compound. And to name ionic compounds is actually pretty easy, because the only rule there is change the ending for the second element to ID, and that is all we have to do, okay. So remember that you always have to identify first what type of compound you have. Right here we have we have lithium and we have chlorine. Lithium is a metal and chlorine is a non-metal, so that is ionic. Great. And so to name this, we're gonna just write the name of the first element, which is lithium. Okay, and then the second element is chlorine, and we're gonna change the ending to IDE because that is the rule for ionic compounds. So we're gonna say lithium, and no, we're not gonna say chlorine. We're gonna say chloride. Okay, so we change the ending from chlorine to chloride. Okay, next example. We have calcium, which is a metal, and then we have fluorine, which is a non-metal. So that is ionic, and the rule for ionic, it is change the ending to IDE. So we write the name of the first element, calcium, and then the second element is fluorine, but we're gonna change the ending to IDE. So we're gonna say fluoride. Okay. Next compound, we have sulfur. Sulfur is a non-metal, and oxygen is a non-metal. So we have two non-metals. This is covalent. We are not naming covalent today. This is just a reminder that you have to check. You have to check the type of compound that you have. So this is covalent, which we're not working with today. Next example, we have rubidium. Rubidium is a metal, and iodine. So we have a metal and non-metal, which is an ionic compound. And to name ionic compounds, we change the ending of the second element to IDE. So we write the name of the first element, rubidium. Okay, and we're gonna change the ending to IDE. So we're gonna say iodide. Okay, change the ending to IDE. That is all we have to do. Super easy to name ionic compounds. Okay. Now we're gonna move to how to write formulas for ionic compounds, and this is actually what students struggle with the most, and it is only because they don't do these three steps. There is three steps to write formulas for ionic compounds. Okay, the first step in every single problem, like I've been trying to show you up here, is to identify the compound that you have, because this is to write formulas for ionic compounds, and it's actually gonna be also for polyatomic and also for transition metals. Okay, so this process also works for polyatomic and transition metals. It does not work for covalent. Okay. So keep that in mind. Alright, so the first step is we're gonna write the symbol for both elements. Second step, we're gonna write the charge for each element, and the third step is we're gonna cross the charges, the ionic charges. Okay, so this is what I mean. Calcium, we're gonna write its symbol. We're gonna write Ca. That's the symbol for calcium. It's here in the periodic table. You guys have to look for the elements, which I guess is challenging for some. The charge is +2. Okay, and we got the charge from up here. Okay, calcium. Let me erase all this so everything is kind of clear, because I have a lot of writing. This as well, so we get a clear space. Okay, so calcium has a charge of +2. Okay, +2. So that is the charge. And then we have nitride. That will be nitrogen, because they changed the ending to IDE. So it's nitrogen, and it has a charge of -3. So we write its charge, and I'm gonna write it in a different color. Nitrogen has a charge of -3. So we already did step 1, which is write the symbol for both elements, Ca and N. And then step 2, write the ionic charge for each element, calcium +2 and nitrogen is -3. And now step 3 is we're gonna cross the ionic charges. Okay, the only thing we're gonna do is we're gonna bring these 3 down here, and these 2 we're gonna cross to the other side. So this 3 is gonna come down here. Okay, and the 2 is gonna come down here. And notice that the charge, that we leave the signs behind, because this number is actually telling us that we have 3 calcium atoms, and this number up here is a charge. And the reason why we cross charges, because I'll get that in a little bit, but let me just tell you that this is your final formula. Calcium 3, nitrogen 2. That is your final formula. This is your answer. Okay, and now why do we do this? Is we do this to balance this out. The compound has to be neutral. So if we do this, and I'm gonna write it here so I have space. Calcium +2, nitrogen -3, and then we cross the charges. We say, okay, this is gonna be a 3, and then this is gonna be a 2. We do this because we're balancing the compound out. If you do this, if you multiply +2 times 3, you get +6. And if you do -3 times 2, that is -6. Well, if you add these two numbers, it comes up to 0. Because whenever these two elements combine, they're trying to not become stable by being neutral. Okay, whenever these two ions come together, they combine in order to become neutral. Okay, so that's why we cross charges. Okay, and I just wanted to explain that. So let's move on to the next example. We have strontium phosphide. So strontium is metal, is on this side of the periodic table, and it has a charge of +2. And then phosphide is a non-metal, it has a charge of -3. So we do the same thing. We write our number or symbols first as R with the charge of +2, and then we have phosphide with the charge of -3. And after we cross the charges, we get Sr 3. The 3 goes from here to there, and then the next element is phosphorus, and this 2 is gonna go with phosphorus, and this is gonna be your formula for strontium phosphide. Next example is cesium sulfide. Cesium is located in this side of the periodic table, and it has a charge of +1. And sulfide is over here, and it has a charge of -2. Okay, so we're gonna write our symbols, Cs and S. I'll do it in a different color. S. So we have cesium, which has a charge of +1, and sulfur has a charge of -2. After we cross our charges, we are going to obtain Cs with the 2, little 2, and S with the 1, and the 1 you don't have to write it down, so this will be your formula for cesium sulfide. Last one, we have nitrogen and dioxide. If you recall, we said prefixes are for covalent, okay? And I'm showing you this because then you start getting confused and you start mixing stuff up. This is nitrogen dioxide. If you look, this is 2 nonmetals, which makes it a covalent compound. Okay, we said that this process of crossing charges is going to be for polyatomic and it's going to be for transition metals, but is not going to be applied to covalent compounds. Okay, we don't do this for covalent compounds. For covalent compounds, this is a reminder, we use the prefixes, so it's actually much easier. We just say nitrogen, okay, 1 nitrogen, and di, which means 2 oxygens. So that is going to be the formula for this. Notice that we didn't cross charges because this is covalent. You always have to identify the type of compound first. Okay, and that is all I have for you today. I hope you guys are good, and I will post these notes online. Y'all be safe.